Hello, everybody. In this video, we will discuss another multi-step synthesis problem. So we started with an alcohol, cyclohexanol, and then we are still making another alcohol, but this time we have added two extra carbon atom. So in this type of problem, the best way we could do this is so you notice the two extra carbon atom were attached to a nearby carbon atom to the oxygens, right? So oxygen is attached to this carbon atom, and the new incoming group, the ethyl group here, attached to the carbon atom nearby. So if you see a OH and there is a carbon chain in the nearby carbon atom, I think you should revert back to the strategy. How can we make that molecule? We can make that molecule if we somehow have an epoxide. So if we have an epoxide and then treat with, okay, I'm going to color code this. If we somehow have an epoxide, and then treat with some type of organometallics like CH3, CH2, MgBr. The reason I chose CH3, CH2 because that's how many extra carbon atom you will need. So when you need extra carbon atom, the best way to add them is think Grignard, okay? Not always, but more often than not, it will make your life a lot easier. So think Grignard. So if I do that, so what would happen? This is gonna attack on the least crowded carbon atom. Again, it doesn't really matter. Both sides are equal, but it's gonna go attack on the least crowded carbon atom. That would push the bond between C and O towards oxygens. So I'm gonna do that one here. So you see the intermediate that you will form is gonna look something like this. O minus, and the two group that we just added, CH2, CH3. All right, so you can see here our structure looks pretty much the same. The only thing that we have to do is neutralize the O negative charge. All right, so that's going to be part 2 of your ingredients. So I will just write H3O plus to neutralize the reactions, and boom, we solve our part A of the puzzles. Okay, now you still have to try to connect your starting material with this reagent. Can we do this? Yes and no. There are a couple of things we could have done. If we have somehow a chlorine or bromine or iodine, and then we could have replaced this to make an epoxide. But I think I would do something like this. So if I have an alkene, and I can simply treat with a peroxy acid with my cycloalkene. Okay, I'm gonna draw this a little bit prettier. So if I have a cyclohexene and I treat with peroxy acid, and boom, I got my epoxides. Now the question is, can I connect these two? Can I make an alkene from an alcohol? Yes, we can. I could have made dehydration reactions, H2SO4 with heat. So that's basically a dehydration reactions, right? So we could get rid of the two hydrogens, not two hydrogen, one of them. So OH with H, so that's minus H2O. Dehydration reactions minus H2O to make an alkene. Again, this is not a mechanism, but this is just the problem solving technique that we are thinking of. So we could have make our alkene, and then boom, we solve our puzzle. So we took an alcohol and then we converted it into an alkene by dehydrating it, and then we create an epoxide, and that epoxide's gonna react with the Grignard reagent, and then we could do this. Okay, so again, every time you have increase in number of carbon atoms, you're making carbon-carbon bond. more often than not, Grignard reagent will somehow get involved. There will be a lot more reaction in the future chapters. We will learn where we can avoid the formation of Grignard reaction, requirement of Grignard reagent. But for now, this is the common approach you should do. All right, let's stop here.